Alright guys, this toolkit is about solving equations with reciprocals, and sometimes that's a helpful thing to to know about, because if you're dealing with fractions, reciprocals are really important. So to find the reciprocal of a number, you simply flip the fraction. Flip the fraction, and for whole numbers, think of them as fractions over 1. Fractions over 1. So for example, the reciprocal of 2/3 is 3/2. The reciprocal of 1, and I'm not going to write an equal sign because they're not equal. I'm going to just draw an arrow. So 1/8, the reciprocal would be 8 over 1. And the reciprocal of -6, we can think of this as -6 over 1. And the reciprocal would be -1/6. Now, the key thing about reciprocals is that when we multiply them, it equals 1. I don't like it when the fractions are slanted like that, but 1/8 times 8 over 1 would give me 1 as well, because I'd get 8 over 8, and that's just the same as 1. And -6, I could write this as -6 over 1 times -1 over 6. And when I multiply that out, I get 6 over 6, which just equals 1. So the key value of a reciprocal is really knowing that we're going to undo a fraction, especially a fractional coefficient, if we can multiply by a reciprocal. So we're going to complete the following division problems by changing the sign and flipping the second fraction. What does that mean? Well, we would just remember that dividing by a fraction is the same as multiplying by the reciprocal. So hopefully remember why that works. But dividing by 2/3 is really the same as multiplying by a fraction, by the reciprocal of that fraction. So we would end up with 6 over 6, and that equals 1. 1/8 divided by 1/8 equals 1/8 times 8 over 1, and that equals 1. And -6 divided by 6, well, we could just write it like, we should write, this should be -6 will equal 1. This one seems a little silly to do it as a reciprocal, but if you did, it would look something like this. Equals +6 over 6. So to eliminate a fractional coefficient in an equation situation like this, well, we know that we can divide a multiplier, so we could think of this as dividing by 2/5 on both sides. But that's a little bit messier, because we know that to divide by a fraction, we're going to end up multiplying by the reciprocal of that fraction. So in cases like these, rather than going about dividing and then showing the step of multiplying, it might be better to just start off with multiplying by the reciprocal, because that's a little bit faster way to undo that fractional coefficient. And you can see it has the same effect of getting that x alone. So we're kind of, if we know 2/5 of x is something, when we multiply both sides by 5/2, we're going to find what x alone is. So we get -1 times 5 over 10 times 2 is 20. And we end up simplifying that to find x equals -1/4. And when we work this out, we should be able to solve this, or double check our work. 2/5 times -1/4 equals 2 over 20, and it's a negative because there's one negative multiplier in there, so that does simplify to -1/10, and that checks out. So to eliminate a fractional coefficient, multiply by the reciprocal. And let's go ahead and do a couple more examples on the back here. So if I want to undo 4/11 times n, to equal negative 16 times 55, I can just multiply by 11/4. And that will eliminate the fraction on this side, and I'll find that n equals, well, negative 16 times 11. You never have a calculator when you need it. 10 times 16 is 160, so plus one more would be 176. Negative 176. And then 55 times 4, well, 50 times 4 is 200, and 5 times 4 is 20, so 220. And I could simplify this by dividing both sides by 2. So then negative 176 divided by 2. Okay, let's break it down. 6 divided by 2 is 3. 70 divided by 2 is 35, so that's going to give me, and 100 divided by 2, so plus 35. 100 divided by 2 is 50. So I'm going to have 85, 88. So this is going to be negative 88 divided by 110. 220 divided by 2 is 110. I can divide it by 2 again, so I can get negative 44 divided by 55. Oh, and this makes it more clear that we've got some 11s here, so I can divide by 11 equals negative 4 divided by 5. And negative 4/5 is as low as I'm going to go. You know, upon reflecting, I see a shortcut here that I could have taken. When I'm looking here at, and ultimately this equation is very much not great. When we get to this point with solving equations, you will find that sometimes it's much better to just use your logical brain to think about what's the relationship that I see. Is there an obvious relationship here? Because I might have seen that 11 times something equals 55. That's very clear. And 4 times something equals 16, and that's very clear. So I could have ended up with 4 times 4 equals 16, 11 times 5 equals 55, and this is a negative, so one of these is negative. So I could have figured out that n equals negative 4/5 without going through that long route of solving and simplifying. So my encouragement to you is know both processes, but don't shut down your brain when you're problem solving, because you will probably find a shortcut along the way. And let's do one more. 3/2 times p minus 2 equals negative 7/8. And this is one where we can't immediately kind of see a quick relationship here. We have to remove that, or add the 2 to both sides. And then we get 3/2 p equals, let's see, this is going to be 2 minus 7/8, so that would be 1 and 1/8. And for when we're multiplying by a reciprocal, we're going to want to change this to a mixed number, or a fraction greater than 1, an improper fraction. So we'll find p equals 1 and 1/8 is 9/8 times 2/3. And when we multiply across, we get 18/24. And that both can be divided by 6, so we get 3/4. And then when I check my work, I should be able to do 3/2 times 3/4 minus 2 equals negative 7/8. So we'd get 9/8 minus 2 equals negative 7/8. And if you weren't sure with looking at this, we can go ahead and we can change 2 into 8ths. So there's 8/8 in 1, so there's going to be 16/8 in 2, so minus 16/8. And then we get to this point of saying, okay, well, that's definitely true. 9 minus 16 is negative 7, and they're all 8ths, so that checks out. We only need to think about the numerator. And that's how we solve equations with reciprocals.